Is it deserved?
All right. So here we go. Here we go. Focus on you can do this.
You're good. There was like
Problem
one.
number one. These are all log roll problems. So there are some other things you need to remember as you're doing it, but they're all going to start by taking this right here to this power and equaling this. So 3 to the negative third equals x. Remember that? Every single one on this page except for F is going to work that way. So 3 to the negative third equals x. What does 3 to the negative third mean? 1 over 3 cubed. Because what does a negative exponent do? Flip you. So 1 over 3 cubed is 1 over 27. What does 3 cubed mean? 3 times 3 times 3, right. So if we need, you can write that down. You don't need to try to do it in your head. Okay. Now, this one is exactly the same problem, and you're looking at your thing, it's so scary. No. What is the base right here? What number is not there that really is there? That is not a 10.
E.
That is E. When do we put a 10 in? When it's LOG. This is LN. LN means E here. Okay? So E to the X equals 1 over E to the 5th. E to the X equals 1 over E to the 5th. Alright? So what power? Negative 5. Very good. How does she know it's negative 5?
Because it flips the sign.
Uh-huh. Right? Because this is 1 over, it means that exponent has to be negative, right? So x equals negative 5. E to the negative 5th is how you would get 1 over e to the 5th. All right, what's this one say? X to the first equals 19. So what to the first gives you 19? 19, yeah, so x equals 19. All right, how about D?
It would be 5 squared equals x.
Bingo, 5 to the second equals x. So, one more time, guys. Start here always. 5 to the second equals x. A log rule. 5 to the second equals x. So what's x? 25. Now, here's your LOG. You're supposed to start with this number right here, but it's missing. What is it? 10. So 10 to the x equals 1,000. So how many times do you have to times 10 to get 1,000? 10 to what power? Third? Don't say 10 to the 10th. That would be 10 times 10, 10. That would be a whole bunch. That would be big. It's 10 times 10 times 10. 10 to the third. So x equals 30. And then this is the one, the only one that isn't log rule. This one looks different, but this is so easy, right? When these two numbers match, the answer is the other one. So 36. whole page is exactly the same, done exactly the same, except for this one. This one looks different, but it's easy. All right, and finally, log base 4 is 64. What's that say?
4 to the x.
4 to the x equals 64. So you have to figure out 4 times itself how many times? 3. 4 times 4 times 4.
Is this a no calc
Yep.
quiz?
Okay, we got it? All right, let's look over on the back side. Now, we already did an exponent quiz, so this is kind of the same stuff. Okay, so what do I do here?
First you flip it.
First, I flip it. When you have a negative exponent, you flip it. So this is 16 over 1. So when it flips, it becomes 1/16.
And then you have to bring that radical into the fraction.
And then since the exponent is a fraction, what does that mean? A radical. So this is gonna be the 4th root of 1/16 cubed. Remember, a fractional exponent is always a radical. Alright, so what's the 4th root of 1? 1. What's the 4th root of 16? 2. Because 2 times 2 times 2 times 2 is 16. And then I have to cube it. What's 1 cubed? And 2 cubed. 2 times 2 times 2. There we go. All right, what about this one? What do I do first? Flip it and make it 2 over 1 or just 2 to the 3rd. So the answer is any flipping going on in this one? Nope. So we're gonna jump straight to the radical. So it's going to be a cube root, remember, this always tells you which root. Cube root of 64/27 squared. So the cube root of 64 is 4. The cube root of 27 is 3. But I have to square it, so the final answer will be 16 ninths. All right, so where do we start here?
You flip the 5.
So this is 5 over 1, so it's going to become 1/5 squared. What is 1/5 squared? 1 over 25. Because it's 1 squared over 5 squared. But we're multiplying by 10 over 1.
So it'd be 2 over 5.
So we just go straight across, we get 10 over 25, but we can reduce that, divide by 5, and get 2 over 5 as our final answer. All right, so what do we need to remember with these exponents? If the exponent's negative, we flip it. If the exponent is a fraction, we make it a radical, right? Okay, just like before, nothing new there. Okay, number 3 is from a very long time ago. From the very first day in this chapter. We're gonna write the equation of the exponential function containing those 2 points. All right, it's been a long time since we did this. Who remembers? Where do we start? What do we do?
But we used to
We use this point first, right? And what we plug it into is this general form of an exponential. So this is what it means when it says write an exponential. Okay? Now, we start with the point with the 0. This is x, this is y. So I put 4 in and 0 in for x. B to the 0th is 1. So this just says that A is 4, doesn't it? And that's what we observed back when we did these. I was starting to come back to you a little bit, remember? So now we know that our equation is y equals A, or not A, 4 times b to the x. Okay, so then what? What do we do next? Plug in the second point. So 16/9 equals 4 times b squared. Not always, but usually there are fractions involved. So let's multiply both sides by 9. So 16 equals 36 b squared. Is that okay? Then I can divide by 36. So I times by 9 to get rid of one fraction, but then I turn around and divide it by 36, so now I got a fraction back. And that actually reduces, and it's probably good if we reduce it. So what is 16 over 36? 4 over 9. And then what do we need to do? How do we find b?
We do
Square root. So b ends up equaling the square root of 4/9, which is 2/3. And then we write our answer, which has to look like this right here. So y equals 4 times 2/3 to the x. Okay? That's old news. Okay, last one. Is this thing growth or decay? Decay. How do we know? What's the key? The number with the x is less than 1. So that tells me it's decay. What percent growth or decay? And if you say 71, I'm going to come back and smack you. Do not say 71. What is the percent growth or decay? 29%. Remember, the percent growth and decay, growth or decay, is how much off of 1 you are. So 1 plus what? Or 1 minus what, right? And since this is less than 1, how much less than 1? 29%, 0.29. Got it? Okay? And what is the initial value? 62. Yep. A, this number right here, is always the initial value. Okay? So tomorrow, We have a quiz, it looks just like this. So what you might do between now and then is just take a few of these problems or all of them, copy them off on another sheet of paper, and make sure you can run through them and do them on your own. The whole first page though is overall, except for that one problem, so that's how you're gonna start every one of those. With your exponents, you know the rules. Right? Okay. All right, so that's that. And now we're gonna get back into, section 3.5, which is a very big, section, part of which we'll use our calculator for. And then we'll get to 3.6, which is all word problems. All right, so according to my records, we are ready for problem E. On 3.5, 1. All right, so 2 times 5 to the x over 3 equals 250. There might be some overlap with our quiz stuff in some of this. Yeah, we definitely is going to be down to a lot of it. Okay? All right. Does anybody, we did a couple like this the other day, but no while. Does anybody have a thought about how we would start this problem?
We divide the 2.
I would definitely divide by 2. So 5 to the x over 3 equals 250 divided by 2, which is 125. Is a special number. Anybody know what 125 is? It's a cube, that's right. What is the cube root of 125? 5. So this guy right here is actually 5 to the third. 125 is 5 to the third. 5 times 5 times 5. Now, look at your problem. 5 to this power is the same as 5 to this power. So does it make sense to you that x over 3 is 3? That those would be equal to each other? So if I multiply by 3, then it looks like x equals 9. Now, the key to being able to do that problem was recognizing that you had a 5 on this side and 125 on this side, but 125 was 5 to the third, so you could make them both 5s. Because when you make them both 5s, then you can adjust the exponents. So that's the key. All right, so let's try it with the next one. 2 times 9 to the x plus 3 equals 54. All right, so what do you think we're going to do first? Divide the 2 over. And 54 divided by 2 is 27. Now we've been at this long enough. You gotta just think, 9 and 27, those are special. Right? But what's 9? 3, 9 is 3 to the second. Okay, so don't be confused. 9 is 3 to the second. And what's 27? 3 to the third. Now, if I get both of these to be the same, then I don't need those anymore. I look at just my exponents, right? Now, be careful here. What happens when I have this double exponent right here? What am I gonna do with those two? Multiply them. So this is gonna be like a distribute. So this is gonna be 2 times x plus 3 equals 3. When you have two exponents back to back, like if you had 5 squared cubed, that would be 5 to the 6th. Multiply these exponents. Since that's a parentheses or a plus there, you're gonna have to do a distribute. So 2x plus 6 equals 3. And then solve it like a regular equation. X equals negative 3/2. Okay? Oh, this next one looks so tricky. But don't let it psych you out. What are we gonna do first?
Divide by 36.
Divide by 36. Kids always divide out that number first. Now, what about 9 over 36? Does that reduce?
What is the best square root?
Not 1/2. 1/4? Doesn't 9 go into 36 4 times? So this is 1/4. Now, your heart should be joyful because what about 1/4? Look what you got over here, 1/2. What's 1/4?
One.
1/2 squared? Let me write it so you get a feeling for it. Because if you square 1/2, don't you get 1 over 4? Now, do these match? And if they match, then I can just build an equation out of the exponents. So x over 4 equals 2. And x equals 8. It looked a whole lot harder than it was, for sure.
Can you only set the exponents equal to each other if the base number is the
Yep.
same? Okay.
That's why every single time, that's kind of been my mission. I want to make these two numbers match. Now, it doesn't matter what I match them and what I make them, as long as they match. Alright, so here we go.
Divide by 27.
Divide by 27. Now, you always want to reduce if you can. So both of these numbers are clearly divisible by 3. Right? Now they're divisible by other things too, but I'm pretending like I don't know. So I'm just figuring it out. I know they're divisible by 3. So 3 goes into 243, 81. Now, oh my, what's 81 over 9? That's just 9. So this is what I have now. These are not the same. You need to make them the same. So what do you know about 9?
Oh, it's a cube.
9 is 3,
3 times
3 times 3, so it's 3 squared. So this is 3 squared. Now what is 1/3? What, 3 to the negative first? Guys, this is where you gotta get a little bit creative. You need to make a match. Exactly. So would you agree that 1/3 is 3 to the negative first?
Yep.
Yeah, because what happens when you make exponents negative? What? So going over? Alright, now what do I do with these? It's a double exponent, they get multiplied. So that's just gonna be negative 1x equals 2. So dividing, it looks like x equals -2. Now later today, I think, we're gonna look at problems that look just like these, except maybe instead of this being 9, maybe this was 7. Uh-oh, we're in trouble, aren't we? Yeah. So we'll look at those and we'll need a calculator for those. But, yep, good. All right, got one more. Would you take a second and see how far you can get with letter I? Don't get freaked out by fractions, etc. Go ahead and see what you can do. You know what to do first, right? I hope. Jack, what are we gonna do first? Well, it might be easier since that's already fractions to multiply by 8. Right? Because that will take care of that thing. Did y'all times by 8 to get started? Now, some of you may have divided by 1/8, and that's just a harder way of multiplying by 8. Now, you've got to be asking yourself, is 64 2 to something?
2 to 6.
If I'm going to do this problem without a calculator, that has got to become 2 to something, right? So 2 times 2 times 2 times 2 times 2 times 2. I'm just putting a whole bunch of 2's up here. Let's see how many it takes. 2 times 2 is 4. Times 2 is 8. Times another 2 is 16, so I'm up to here. Times another 2 is 32. Times another 2 is 64. So how many did it take? 6. So 2 to the x over 5 equals 2 to the 6th. Which means that x over 5 has to equal 6. Which means x must equal. If you're not doing this on the calculator, then you have got to be able to make these numbers match. 2 is as simple as it gets, so I'm going to leave the 2 and work on making my 64 into a 2. If I had a 27, I would make it into a 3, right? We got certain numbers that we keep seeing over and over again. Okay? All right. Now, 2A, problem 2A is going to be on your quiz tomorrow, or could be on your quiz tomorrow. What's our strategy with this guy right here? 7 to the x equals 49. So x equals 2. Right, that's 2A. All right, what about 2B? Okay, so Jack, do the same thing with this one. What's this one gonna be?
2 to the 3rd.
Yep, and what's 2 to the 3rd? 2 times 2 times 2. 8. So those 2 problems could definitely be on the first page of the quiz tomorrow. kinda harder. At least it looks harder. However, we're gonna log roll it, just like we did all the other ones. So what is this one gonna say if I log roll it? 4 to the second, all the way over to here, equals x plus 2? So what's 4 to the second? 16. So what's x? 14? Did everybody keep up with that? Alright, try D on your own, so you can set that one up. Do it the same way. Do it exactly the same way. Daryl, how'd you start this guy right here?
I did 3 squared equals 1 minus x.
Beautiful. And then?
I got 9 equals 1 minus x.
Yep.
And minus 1.
Okay.
And got 8 equals negative x.
Uh-huh.
And then divided the negatives with 8 equals negative 8 equals x.
Okay. You win. Perfect. Beautiful. Stunning. How many of you got negative 8 as your answer? Good work. Easy, easy, easy. Now, let's look at the next one. Think about the problem. You know what you need to do first. What do we need to do first? Divide out the 2. When you have this extra number, just like your exponentials, when you have this extra number hanging out here in front, get rid of it. Now, it isn't going to impact over here on this side. All it does is cancel this out. That part stays the same. Log base 4x plus 1 equals 2 now.
Then it'll be 4 squared equals x plus
4 to the second equals x plus 1. $16 equals x plus 1, so I got 15. How about you? Yep, you're solving logarithmic equations. Log roll, log roll, log roll. Alright, F is an absolute monster, so take a second and see how far you can get with that.
You gonna go?
Now this one is a little bit different in how we start. How did you start this one? Lewis, did you ever thought? We wouldn't times by negative 3. Wouldn't we want to divide by negative 3? And you actually can do that first. You have to make sure you do it to everything if you do it first. I would move this first myself. Did you notice that we don't usually have a 0 over here? So I would move that over. It's not absolutely necessary to do that first though, but I think it makes it easier if we subtract this 6 to the other side and then divide by negative 3. So we have log base 6, 4 plus x equals 2. Now, look at that carefully. Does that make sense to you? I moved the 6 to the other side. I divided by -3. And now I have my log all by itself. There's nothing attached to it.
For these problems, do we always have to have a number on both sides of the equal sign to be able to solve it?
If you're gonna solve it, you do, yeah. All right, so what's next? 6 squared equals 4 plus x.
So then it would be 36.
36 equals 4 plus x.
And then subtract the 4.
And x equals 32. Phoebe, did you get that? You are the queen of logarithms. Good work. Are you also the queen of logarithms? You. Did you get it too?
Yeah.
Okay. Any issue? Any questions? 'Cause now we're moving to a different kind of problem. So do you feel like we've got a grip on that? Okay, so now we've got 3 to the x equals 6. Okay, this is totally like nothing we've done before. We have done 3 to the x equals 9. We did that. What would the answer to this be? 2. And that's easy because 9 is a power of 3. 7 is not. So what do? Here's what we do. If you cannot make these match, there's no way to make 7 3 to something. So we're going to write log on both sides of the equation. And physically write log on both sides. Okay, so write log on both sides. Now, think back, I think it was last time, but it could have been the time before, when we had something like 3 log n plus 2 log n. And we were putting those together into one logarithm. Do you remember what went in here? Multiplication, so we had m's times n's in there. And then what happened with these guys? Okay, flip back a page or 2 in your notes and see if you can remember what happened. It would be back on page 27 of your notes. They turned into exponents. So this became m cubed, and this was n squared, remember that? So, here's the deal. If I have the log of something to a power, that exponent becomes a number out in front, a coefficient. So x log 3 equals log 7. And then I divide both sides by log 3, and x equals the log of 7 divided by the log of 3. So you type stuff like that in before. I'll just go to my calculator. And what's my caution? Anybody remember when you typed this in before? Gotta make sure you finish the parentheses, right? So when you type log 7, make sure you close that parentheses before you do divided by log 3. And we're gonna round. Does it say? So let's round to the nearest, 10,000, so 1.7712. Is that what you got?
If it's a problem where our first one has the exponent of x, is that always gonna be the same, so can we just always divide it like that?
Yeah, it's always gonna be that way.
Okay.
Yeah. Now the problem is, some of them, those exponents are gonna change a little bit, so you wanna be careful. But yeah, as long as it's plain x, it's always gonna be that. Alright, so let's look at the next one. 4 to the x equals 10. So we're going to, there's no way, it's not like, if we had 4 to the x equals 16, life would be perfect, but that ain't what we have. So we're going to take the logarithm of both sides. So physically write log on both sides. And then our favorite property of logarithms says, if it's an exponent, it becomes a coefficient. So x log 4 equals log 10. And we're trying to figure out what x is, so we'll divide by the log of 4. I got 1.6610. When we're rounding, guys, you are confused, then write it down. Write down the number that you got. Count over 1, 2, 3, 4. Draw a line. If that number's more than 5 or more, if that number's 5 or more, this has to go up. So 09 is going to become 10. Alright, would you try C? It's exactly the same thing. You're going to do it exactly the same way. I know there are decimals. That doesn't matter one single bit. You're going to do it exactly the same way. Here, we've already done this. We have a quiz tomorrow. Alright, did you write log on both sides? Did you pull your x out front? And did you divide? And what did you come up with as your answer? What'd you get? 4.1491. Now, just so you see how this is all working, take your calculator and type 1.73 raised to the 4.1491 power. So take your 1.73, just type 1.73 raised to the 4.1491 power. And what did it equal? 9.72, right? We just checked our answer. It works. Now, it's off a little bit because we rounded this off, but it's pretty darn close. Okay, so what about D? D looks a little bit different.
Will we divide the 6 first?
Yes, you guys, this is a common theme. When you have this extra number hanging around in the problem, get rid of it. So we're gonna divide by 6. So 2 to the x plus 1 equals 3. Now, if this were a 4, I would be jumping for joy, because 4 is 2 squared, but it's not. So I have no choice but to take the logarithm of both sides. Now, what happens to the exponent? The whole exponent becomes a coefficient. So x plus 1, the whole thing, log 2 equals log 3. You with me still? So I'm going to go ahead and divide by log 2. So x plus 1 equals that right there. Log 3 over log 2. So x plus 1 equals whatever that decimal is. .5850. But my job is to figure out what x is. What am I gonna have to do? One extra step this time? Subtract a 1. So .5850 is our answer.
It's log 3 divided by 1.
Alright, 2 more and I'll stop. Okay? 2 more, we'll finish this. 81 e to the x equals 200.
Could we put an L in both?
Not yet. We're gonna. That's exactly what we're going to do. But what are we gonna do first? Divide by 81. You gotta divide by the 81, guys. Now, do not get a decimal for that. You're gonna be doing a ton of problems where we're going to end up with weird things over here. And in our word problems especially, it's gonna cause great round off error. So we're not gonna do that. We're just gonna, I'm gonna divide by 81 and write this down. That doesn't bother me one bit. Now, Kate said, instead of LOG on both sides, why don't I LN on both sides? Now, first of all, it makes no difference. So if you're an LOG person, LOG away. Go ahead, LOG, LOG, LOG. Why did she say LN in this problem? Because there's an E, and we know that LN means log base E. Now, here is why I would recommend you do this. You don't have to. See this right here? LNE cancels. Every time you have an LN and an E touching each other, they're gone. They're inverses of each other. So what is left on this side of the equation? X, which is what you want. So you're going to go to your calculator, and the only thing you have to type in is ln 200 divided by 81, and your answer is 0.9039. If you use log, you're going to have more to type in on the calculator because nothing will cancel. You will eventually get the same answer.
So you don't have to reduce the fraction because you're in a
It doesn't reduce.
Oh, it doesn't.
It doesn't reduce.
If it did though, we
I
would
would
make it up.
probably, since I'm going on to my calculator anyway, it doesn't really matter.
Okay.
But that doesn't reduce anyhow. Alright, one more, last problem. What do you think we should do first? Divide by 17. So e to the x equals 93 over 17, and just leave it. 93 over 17. Now what? ln both sides, that would be the easiest. Because, see this right here? They're gone. So x equals ln 93 divided by 17, which is 1.6994. Stop there. So we have still not finished 3-5 yet. We have a whole bunch more to go. It's a big section.